All right, I'm going to show you how to solve this within few minutes. Okay. All right, this is a problem under electricity, of course, transformer in physics. So let's solve these likely questions in JAMB and WAEC. Let's solve it. The question number 1 says a transformer has a primary coil with 500 turns. So let's write our solution. A primary coil. So take this to be the number of turns in primary. We are told that it has a primary coil of 500 turns. So take the numbers of turns in primary to be NP, which is equals to what? 500. Okay. And a secondary coil with what? 2,500 what? Turns. So take this to be the numbers of turns in secondary. NS to be equals to what? 2,500 turns. When the voltage input to the primary coil is this is telling you that the voltage at the primary coil in the transformer, we have an input voltage and we have output what? Voltage. The input voltage is the primary what? Where is the primary voltage you are talking about, and the output is the secondary voltage. So this primary coil, the input voltage is given to be 120 what? 120 volts. So let's take it to be, you can either take it to be EP or you can take it as VP. So I will take it as EP now. In this case, let me just take it as EP. I can take it as EP or VP. VP means voltage at the primary coil, or VP. So let me just take it to be EP equals to what? Equals to 120 volts. Okay, these numbers of turns, they don't have units. All right, so we are asked to do what? The output what? Voltage is, that is the voltage at the secondary coil, is what we are asked to calculate. So let's do that. There's a formula that links them together. The formula says the numbers of turns in the primary is equal over the numbers of turns in secondary is equals to the voltage at the primary, EP, over the voltage at the what? Secondary, ES. That is just it. This is the only formula you need. And our NP is given to be 500. That will be 500 over NS, which is 2,500, equals to EP, which is 120 of volts, over NS is what we are asked to calculate. ES is what we are asked to calculate. Sorry, ES is what we are asked to calculate. Okay. Now in this case, I can say 0 cancel 0, 0 cancel 0. I'm left with 5 over 25, and we are also left with this. So we have 5 over 25 equals to 120 over 120 volts over what? ES. All right, so let's cross multiply. 5 times ES will give us 5 ES, and 25 times this will be 25 times 120 volts. Okay, now let's do it like this. Divide both sides by 5, divided by 5, divided by 5, to make ES subject to the formula. We have ES equals to this, cancel this. We are now left with this 5 here 1, 5 here what? 5. 5 here 5. So we are left with 5 times 120. 5 times 120 volts. And 5 times 120 volts will give us 600. So the correct answer is 600 voltage. So the output voltage, which is the voltage at the secondary, is 600 watt voltage. Okay, so let's solve the next one, which is question number 2. Let's solve question number 2. For question number 2 now, we are told that in a transformer, the primary to secondary transformation ratio is this. In a transformer, the primary to secondary transformation ratio is given to be what? 2:3. 2 what? Ratio 3. That is the numbers of turns in primary to secondary. The numbers of turns in primary to the numbers of turns in secondary is given to be 2:3. Take note of that. In a transformer, the primary to secondary, the numbers of turns in primary to secondary transformation is given to be this. So which means the numbers of turns in primary to numbers of turns in secondary is given to be 2:3. What is the voltage across the secondary coil? Now we are calculating the voltage across the secondary coil. If that across the primary coil is given to be this, you can see that it's almost similar to question number 1. We are given the voltage at the primary coil to be this, and we have to calculate the voltage at the secondary coil. This is the same thing as what we did. Remember that our VP, I said you can call it VP or VS, okay? You can call it VP or EP to represent your voltage. So let me call it VP in this case now. VP, that is voltage at the primary, is given to be 22 kilovolts, okay? Now, using the same formula we said earlier, that our NP, numbers of turns in primary to the numbers of turns in secondary, is equals to the voltage in primary. I used E earlier. I can also use V. It's still the same thing. That one means EMF. Why this one means voltage? It's almost the same thing. So now VP, numbers of the voltage in the primary to the voltage in secondary. Okay, so the voltage at primary to secondary, we're given the number of turns at primary to secondary to be 2:3. That is 2/3. So I will also write it as 2/3 equals to the VP over VS. Our VP is 22 kilovolts. Is 22 kilovolts over VS. VS is not given. We are looking for VS. So what we have to do now is that cross multiply. 2 times VS, we have 2 VS equals to 3 times 22, we have 22 kilovolts. 22 kilovolts times 3. Okay, so to make VS subject to the formula, you divide side by 2. We have VS equals to 22 times 3/2. Now let's cancel like this. 2 here 1, 2 here 11. So 11 times 3 will be 33. It will be what? It will be 33 kilovolts. 33 kilovolts. And the correct answer to that is option C. Please, you find the video helpful. Of course, I know that this video is helpful. Please consider to like, comment, and share. See you in my next video. Thank you.